What replica sets guarantee or tell you is the availability of specified number of identical pods. For self-healing or load distribution, or to not get into the high availability and single point failure kind of scenario, if you have one application pod and that pod fails, then the application user who's accessing that is going to go nowhere. So what we want is multiple copies, identical copies, replicas, multiple of them, right, running on our cluster. Meaning create multiple of them. If one fails, the other are there to serve the end user, take over the load. That's the story, right? So when you create a controller called as replica set, it guarantees you that number of replicas what you asked for is available. What happens is this controller is going to take this input as your desired state, and it's going to ensure that your desired state is met. Say, for example, if I tell 3 replicas is what I want, it is going to ensure at any given point of time, I have 3 replicas when I come back and look at the cluster. If now the node 2 fails and 2 pods with that node 2 go away, so my desired state was 3, but my current state of cluster is 1. So what does it need to do? It needs to steer my cluster towards my desired state, meaning add 2 more pods which have been lost. That's what your replica set does. It gives you self-healing, right? You don't need to worry about it. You don't need to get involved. You get involved only when you post your YAML file with your desired state, and then let the replica set controller keep an infinite watch loop. 2 o'clock in the night, one of the server fails, along with your replicas die along with it. You don't have to log in and go back and create those replicas on some other server. It'll automatically self-heal on some other available healthy nodes, right? And also, you usually have replicas for distribution of load as well, right? Say, for example, 1,000 users are accessing my application. 3 replicas are enough to handle the incoming load. And say we have some sale now, 1,000, more than 1,000, we have like 1,000,000 users accessing it. Those 3 replicas are not able to handle the load. So based on our traffic, we decide to scale up, add more copies of it. So I can change my desired state. I say instead of 3, give me 10. Then it is going to look at your desired state, and it's going to add that many number of pods, meaning it's going to help you scale up or scale down if you don't want, using the controller called as replica set. Otherwise, if you're just creating the pods by yourself, you had to do all of that manually. That's the reason we don't do it. We don't like to do things manually. We create controllers on top of them, which will deploy these pods and keep on watch on them. All right, that's your little story around replica set as a elementary controller we're looking at. So how do we define the replica set? What does it look like and feel like? At the bare minimum, the replica set has AKMS. Most of the objects have in the Kubernetes world that AKMS, API version, kind, metadata, and spec. This is how the replica set spec is going to look like. Under the replica set spec, you will have an integer value which defines the number of replicas what you want, called as replicas. Integer value. If you don't specify this, default option is 1 replica, 1. If you define like I want 5, 10, 20, 30, that is the number of replicas. It guarantees to you at any given point of time, you come back and look at your cluster, the desired state, the number what you asked for is available on your cluster. Guaranteeing you in a way, if things break, fixing and recreating them and self-healing them automatically. So under the spec, one of the elementary value what we'll have called as replicas, it takes integer as an input. And if I don't specify that field, default is 1 copy what it's going to create. Elementary, good. Now I'm telling my replica set controller, listen, I want at any given point of time, I come back and look at it, I need to have 5 parts. That is what I'm telling my replica set. So when a replica set controller gets created, it will ensure controllers, what do they do? If we recap the architecture, 4 things they do. Obtain what your desired state, observe what your current state, try to determine if there are any differences. If there are, reconcile them. Right? That's what they do, correct? Now, the desired state is 5. It needs to go obtain what is the current state. It needs to go see, user is asking, I need 5 pods, and it goes and looks at the cluster. There are already some pods running. For example, in our case, if I create the replica set right now, there are already some pods running. 3 pods are already running. But how does the replica set know which pods is the user talking about? How does the replica set? There can be hundreds of pods running out there. And I'm telling I need 5 pods. So how does it know which pods I'm talking about? That's the problem. So the solution for that is we give the filtering condition for replica set. We tell how to identify those pods. We do so with the help of something called as labels. We do so with something called as labels. Under the metadata, where we saw name was mandatory, now we add one more feature called as labels. Labels are simple key and value pairs. There is no fixed key or there is no fixed value. They're simple alphanumeric values which can't be larger than 63 characters, can't begin with symbols. It will be alphanumeric name or number. It can be simple key value pairs under metadata of your pod. Under name or above that, you can add something called as labels and mention those key value pairs. For example, like env is equal to prod, version is equal to v1, app is equal to red. Here, if you have 4 different applications, red, green, yellow, blue, and I want to categorize, separate them out, I can apply labels on those parts, like app is equal to red, app is equal to green, blue, and yellow, which helps in identifying or categorizing these parts. For example, if I have a rack full of books wrapped in a brown color wrapper sheet of books belonging to different subjects, right? And if I have to go pick one book, say which belongs to a subject called as physics, maybe. So if I have hundreds of books and all of them are wrapped in a brown color wrapper sheet, I can't really identify them. I'll have to open each one of them and take a look inside it. Instead, if I had applied some sticker on top of it, some marker, and I've written like this book is physics, this is math, this is science, and geography, it's easy for me to go filter out of those 100 books and fetch that one book I want, right? Similar, I'm just trying to relate and give a real world example. So you apply labels. I told you minimum 8 lines. Now labels kind of become not mandatory, but when you make use of controllers, they become mandatory. So under metadata, we add objects like labels. And that label is what we give our replica set spec as selector. We say, listen, I want 5 pods at any given point of time. Fine. Which 5 pods? The pods which have this specific label. So making use of those labels, it goes and acquires those pods. It needs to identify, right? What is that current state? I'm telling I want 5 pods which carry label app is equal to my app. Then it goes and filters out of the hundreds of pods what you have. It goes and checks, hey, are there 5 pods with this label? If there are, 5 is what I've asked for, 5 is what it is, then the replica set controller does not need to do anything. Life is good because that is the desired state of my cluster. But 5 is what I've asked for, and the number is not matching. Right now, in my example right now, 5 is pods what I have asked for, and we don't have any of those here. Of with that label what I've asked for. Desired state is 5, current state is 0. What does it need to do? It needs to steer my cluster towards my desired state, meaning it needs to create those 5 pods. How does it create? Well, that's where you specify a pod template. In the template, it's exactly the same pod manifest file what we looked of right now. All those 500,000 lines what you could write, you will define under that pod template whatever you had. Under template, you define that. When it needs to create pods, it is going to make use of this template and create it. Earlier, you were writing the kubectl control command and telling your API server to create the pod. Now, the replica set controller will tell, hey, listen, you got to do this. Go get this pod created. That's what your replica set controllers do. They give you your self-healing and manual scaling. How does the manifest look like? This is how it looks like. Till here is elementary stuff. Kind here is replica set. R and S is capital, and it belongs to a group called as apps, version called as v1. How do I know? There are many different resources what you're going to create, which one belongs to what is the kind, what is the API version I need to make use of. We know that commands, what we can do kubectl API resources, it shows us, or we can do kubectl explain, it shows you that. So I don't need to take you there for every command. I've showed you in the pod. Same thing applies for everything else out there. Okay. And then name of the replica set, elementary, some name what you give, forget it, forget till here for now. Under replica set spec, we have 3 things: replicas, selector, template. What is the number of replicas I want any given point of time? Integer value. Don't specify, 1 is default. Then There are hundreds and thousands and millions of pods. How do I identify which three pods you're talking about? I'm telling it to match labels. Match the labels. There's labels called as app, web app. This is the key. This is the value. So whichever pods which have this label, that is what I'm referring to, is what I'm telling my replica set. And it's going to make use of this information and go check which are those pods which have that labels or not. If 3 is what I've asked for, 3 is what is available, it does not need to do anything instead of just keeping an eye on it. If 3 is what I've asked for and 0 is what I get, it needs to create 3. How does it create? Makes use of the template. Now this template looks familiar to us. Here is the YAML file. Kind is replica set. Again, you can do explain, you can do API resources, recursive, all of that stuff. I'm not going to repeat all of that same thing for every command we do. Replicas, selector, template. Okay. Now I'm telling create 3 replicas for me. Which 3 replicas you're talking about? You have many pods. I'm telling the pods which have the label app is equal to tier is equal to web server. Some key, some value I make use of. But how do I know what pods, which label these pods carry? How do we know? Is we can make use of kubectl get pods command, and we can also say, hey, can you show me the labels what you carry? Show labels. It shows you what labels it has. You can also do kubectl describe pod, and it shows you that labels as well. Many different ways of letting that. But right now, if I create a replica set with 3 as my desired state, the current state of cluster is 0 because I have no pod which is having a label called as tier web server. Right now I don't have. So let me go ahead and create the replica set. Kubectl apply is a better way of doing things. Why we'll understand a little later. Make use of whatever it is there created. Just like the way we did kubectl get pods, I can also do kubectl get RS is short for replica sets. I can do replica sets as well. I can do RS as well. It shows you, listen, you have one replica set. Your current desired state is 3. Currently there are 3, and of the 3, all 3 of them are ready is what it is showing you. So I created a replica set like the way I did kubectl. Can you describe me the replica set? I can, like that way I did for pod, I can do describe for replica set as well. So it shows you the details around the replica set, telling that this is the label selector I made use of. This is the current replica counts what we have. 3 is what desired, 3 is what it is currently. Of the 3 what we have, they're running, they have not failed. And what is the template you made use of is what it tells you. It also tells you that these pods were created by this replica set controller. It triggered the creation of 3 different pods. Because when we created, 3 was my desired state, but current state was 0. So it got these 3 pods created using the template. So if I go back and look at this, kubectl will show me those pods. What do I see? I see those 3 pods. Name of my replica set and some random hash value. 3 pods have been created. Now these are not the orphan pods. These are pods which have an owner. The owner is the replica set who is keeping an eye on all of these guys. 3 is my desired state. For some reason, this pod is gone to node 2, and that node 2 fails right now. It's gone, died. I'll simulate that by deleting this pod. That pod's gone. So what happened right now? 3 was my current desired state. The current state became 2. Replica set is keeping an eye. What did it do? It went ahead and created that pod one more time. This new pod got created. What happened right now was self-healing. Automatically it got recreated. So now later in the night somewhere the server crashes, the pods die. You don't have to log in and recreate those pods somewhere. If you have created a replica set, which is keeping an eye on them, and it looks that when the node died, my pods died along with it, changing the desired state and the current state equilibrium. Desired state was 3, current was 1. It had to create some more. It went and created it. We simulated that by deleting a pod, and we see it automatically recreated to match your desired state. That is your self-healing feature. But replica sets also offer me manual way of scaling things as well. If I do this right now, get all shows me few resources out there. This is the replica set what we created. This replica set created these 3 pods out there for me. And I can do this as well. Kubectl get pods, show them, show the labels. Now we see these have those labels. This is what the labels it's going to make use of to identify it. That's your self-healing, what we saw a little bit. Now my desired state can change. Now the incoming load is too high. Manually, I can decide to change my desired state. From 3, I want to scale it up, add more replicas. How can we do that? There are different ways of doing the same thing. There are many ways. There's one way called as kubectl scale command. That is what we will make use of. It's elementary. Then there's another way called as edit. Edit that resource. I'm going to show that option to you as well. Then we also can modify the YAML file and reapply. This works if I had made use of only the apply command in the first place to create this resource. Okay, let's look at all the 3 options we have, and I'll tell you what to make use of in the exams though. Let's look at the apply first. So I created this with the help of a YAML file. While creating, I made use of an apply command. Now I want to change my desired state. For example, from 3, I want to go to 6, scaling up. So I change the YAML file. I come back and make use of apply command again to create it. It reconfigures that and it changes my desired state from 3 to 6. Meaning now when I go back and look at the pods, new pods were created because my desired state is now 6. So it needs to create 3 more pods to match my desired state. So what we did was scale up, but this was manual in nature. I understand that. And we made use of a route called as an apply, modified the existing YAML file and re-triggered. This would work only while for creating the resource if I had made use of an apply command. Why? We will understand it right now. Second way is to look at the edit command. There's another command which I'm going to introduce you to called as kubectl edit. You want to edit the resource called as web server, what we have. So what does the edit command do? So when you created this, when you posted it to the API server, it took and stored all of this information in HCD. In an HCD database, and schema, it created this information out there. And apart from whatever configuration you had specified, it also injected all the other values as well, like unique ID, the creation timestamp, the owner reference, all that default things what it needs. It is all stored in your HCD. So when I say I want to edit this resource, what does it do? It fetches out the same content from your HCD and displays in which the default editor of your server. In my case, VI editor is a default. It brings out this. Lets you edit. That's your edit command. It's a nice command because if I mess things up, for example, replicas needs integer, right? And I enter some junk data like this, and I want to save it. It's not going to save. It's going to say, hey, what you're doing is wrong. So that way, the edit commands are pretty cool. It tries to protect you. But edit command, like I said, brings out the details from the HCD and brings it out in the editor for you. That's what it does. And you can make use of edit command and can also modify, for example, like this. I will scale down right now. I'll shift to 2. 2 replicas is my desired state right now. I save and exit. That will be edited in my HCD. The controller is looking at it. It says, oh, okay, the user desired state is right now 2, but I have 6. So what do I need to do? I need to discard 4 of them to bring the cluster towards the desired state. That's what it's going to do. That's the edit command. Now coming back to the apply command, what we made use of, and I told you if you modify the YAML file and reapply using the apply, it works. The reason it works because when you created it using the apply command in the first place, it stores annotations, as in some additional data, as comments is the English meaning of the annotation, right? So it stores something called as last applied configuration. So it looks at that configuration and reconfigures itself. This gets automatically created, this last applied configuration, when you create any resource using the apply command. If you had done that using the create command, this last applied configuration will not be stored. And then if you modify the YAML file and try to recreate that one more time, it's going to give you an error that, hey, it's already created, I can't do it one more time. And then the option you have is to delete and recreate. But if you make use of apply, it lets you change few subtle things and reconfigure it. That's the reason I said apply is the used recommended way you should make use of it. That's the apply, the third option what we saw. That's the edit we have changed right now. That's the second option. I'm going to save it. It says edited. Now go back and look at kubectl, show me the desired state. It's set to 2. So what happened if I go back and look at the pods? Few pods are trimmed down. The pods are removed randomly to bring to what your desired state is. So we saw the scale up, we saw the scale down as well. Now, one question which most frequently comes up is, hey, when you're scaling down, what if that pod was serving the end user? What happens to that? So like the way we understood the birth of pod, we need to understand the death of pod as well. So what usually happens is when you scale down, when you terminate a pod, the pod does not get killed right away. The first thing it does, it sends a termination hook. It says, okay, you got to back up. The moment the termination hook is sent to that particular pod, the ready flag, which if I look at this, if I just do kubectl describe, I'm trying to explain you one more concept when you're trying to look at something else so that we kind of understand it better. Pod goes through series of conditions where it tells you there's a ready status flag, Boolean object is set to true. That's when this pod is ready to accept traffic. That's when it shows here ready 1 out of 1, right? So when I say I want to scale down, meaning when I want to kill a pod, the termination hook is sent to it. First thing it does, it sets this flag to false. It makes it not ready. So what happens when it's set to false is no new traffic comes to this pod. So first it prevents new traffic from coming to that pod. Once that is taken care of, if there's an in-flight transaction out there, which that pod is currently serving, which needs to get killed right now, which needs to die, it is not going to kill it right away. By design, by default, it waits for 30 seconds, maximum of 30 seconds. That is called as termination grace period seconds. Can we change it? Of course, you can do all of that, but 30 seconds is the default. Now it's going to wait for your application, that in-flight transaction, what you have to finish. If it finishes within 30 seconds, the moment it finishes, the pod shuts down. That's what it does. So the in-flight transaction is kind of safe. No traffic, new traffic doesn't come, that is prevented. And then whatever is running, it waits for it for 30 seconds. And if it still runs after 30 seconds as well, it's going to kill that. Stop is what it does by default. If you still are continuing, it's going to kill and get out of there. Then the user will find disruption. Otherwise, usually the applications don't take more than 30 seconds to respond back. If that is the story, the moment it responds back in a millisecond or two, then once that process, that in-flight transaction is completed, it's going to shut down and terminate the pod. That's the death of your pod. So that way your transactions are safer. If it goes beyond 30, then yes, it is not. Then as part of your desired state, when you set up, there's also one more option called as termination grace period seconds. You can specify that and increase it again based on your application. Well, I try to explain you one more concept where we're looking at it. But that is your scale down termination of your pods. So we looked at the edit way. We looked at the apply way. Let's look at one more option called as kubectl scale command. This is usually what we make use of. Scale command, which lets you scale your application up or down. I can say, hey, listen, I want to scale. Scale what? Type. That is ReplicaSet, which there can be hundreds of ReplicaSet. Which one are you talking about? Well, I'm referring to this ReplicaSet by the name web server. Then what is the replicas you want? I want 9. And I can scale up like this. My desired set change. What happens? New containers are getting created right now. All right. That is your scale command. That is your elementary controller called as ReplicaSet. What it gave me was self-healing, and that is automatic out of the box. And it also gave me something called as manual scaling. That's what my ReplicaSets did.
So guys, this was a clip taken from our step-by-step comprehensive program that has 16 modules, 60 plus lessons, 35 plus hands-on labs, CV and exam preparation, and the most important, on job support. So this comprehensive program is specially curated for you so that you can be from beginners to a master, and you can master every skill set that has been required here. And if you're somebody who would want to start off their career in the domain, then we have something really special for you. We have our free class on Docker and Kubernetes certification to get you higher paid jobs. And don't you worry, this interactive session will help you in gaining the understanding of why learn containers and Kubernetes, what is Docker container architecture. We'll be discussing about pod with highly available and scalable applications on Kubernetes. We'll be having demo so that you can perform really well. And now if I'm talking about that what special do we offer, we have the comprehensive learning path for Docker and certified Kubernetes administrator course. So in week 1, we'll be talking about microservices and Docker. Week 2 is about Docker, networking, storage, and app stack. Week 3 is about Kubernetes architecture and installation. In week 4th, we discuss about security, troubleshooting, and high availability. Week 5th is about networking, that includes all the networking policies, securities, context, and whatnot. And one thing that I have to mention here is that with every session, we have labs so that you can practice whatever is being discussed in the class, and this give you a knack over everybody because you will have the practical knowledge. Coming to week 6th, we are talking about deploying of daemon processes and whatnot. Week 7th is about application stack. Week 8th, we talk about advanced networking, of course, followed by some different laboratory sessions. And in week 9th and 10th, we are completely focusing on your certification preparation. That includes project work. Then we have certification practice part 1 and certification practice part 2 as well. And in week 11th and 12th, this week is completely dedicated for your CV preparation and your project work, because project work is something that is going to help you with all your exams and of course interviews as well. And now talking about the hands-on labs, and as you can see on the screen, we have almost every topic covered. So with every topic, you'll have a fine-grained understanding of whatever topics we are covering, and each topic you can have a practical knowledge that is going to help you in your examination and of course in your jobs. We also have sample exam papers in PDF format. And here you can definitely see on the screen that what kind of questions we have, and these questions are going to make you prepared for your exam and your interviews. So if you really want to have a basic and if you really want to see what all we're going to cover, then we have this free class where we'll be talking about why learn Docker and Kubernetes and Docker containers architecture, image and containers and whatnot. So if you want to register for this free class, then just have to log on to K21Academy.com/K8S02. You'll be seeing this kind of interface. Just click on book your free seat now, select an event date, add your name, your email address, your phone number, and click on yes, save my seat. Moving ahead, you'll be seeing this kind of interface where you just have to save this link on the extreme right, add it to your calendars, and I will see you in the free class. Till then, keep learning.